So far we've learnt about chemical reactions and how we can identify if a reaction has happened or not. So we learnt about 5 different clues. But another important thing to look at with chemical reactions is how quickly they happen. Because something scientists have discovered is that the speed of chemical reactions can actually be changed. So the speed of reactions can change. And this has a few important benefits, particularly for factories and industries, but also for us as well in our everyday life. So firstly, if we're looking at factories, and here's a picture of a factory that makes plastic bottles, they need to do chemical reactions in that factory to make those bottles. And if they can make those chemical reactions happen faster, that means they can make more bottles and make more money in the end. So, firstly, faster reactions can mean more money. Which is good for businesses, definitely. But on the other hand, if reactions go too fast, then they can be dangerous or not what we want. So, on the other hand, fast reactions can be dangerous. Because when we look at all the petrol in our car, we don't want that petrol to start burning. We want it to react slowly and only inside the engine. So it's important that cars are designed to make sure that that doesn't happen. And also, when we're cooking our food, we don't want reactions to happen too quickly because we can burn the food and then it tastes terrible and we'll have to waste it. So let's look at how we can actually change the speed of reactions. And there's 4 main ways we can do it. The first thing we can do is change the particle size. So if we have some big particles, then there's less chance that when they're moving around that they'll bump into each other and make a reaction happen. But if we break up particles into smaller pieces, like if we crush it up in a mortar and pestle, crush into smaller particles, then there's a lot more surface area on those particles. And more surface area, that means it's more likely that particles will bump into each other and then they'll react. So, one common use for changing the particle size is when we chew our food. So we chew because this means the food particles that we put in our mouth get crushed up into really small pieces, and that helps our digestive system to break the food down a lot quicker. If we just swallow big lumps of food, they sit in our stomach for ages and they don't get broken down in a chemical reaction very quickly. The next thing we can do is change the temperature. So here we've got, if you pour in some sugar into a cup of tea, then if you have a higher temperature, that means the particles are moving a lot faster. Because remember about our particle model, Particles that are hotter are flying around and moving really quickly. So higher temperature, that means more chances that particles will bump into each other and react. So we have a faster reaction. So when we put sugar into a cup of tea, if the tea is really hot, then the sugar will dissolve a lot more quickly. Another couple of things we can do is change the concentration. So we've got a picture here of concentrated sulfuric acid. And if we have a beaker full of acid and it's dilute, then there aren't many acid particles in that beaker. The rest is water. That's our blue dots here. But if we have another beaker that's got highly concentrated acid, then we have lots and lots of acid particles in there. And if there's more acid particles, that means there's more chance that they'll bump into another particle and react with it. So higher concentration causes a faster reaction as well. Lastly, there's a special type of chemical, well, a group of chemicals that are called catalysts. And these are chemicals that on their own help to speed up reactions. But they don't actually participate and they don't change during the reaction. So, catalysts are chemicals that speed up reactions. And a common example is in our saliva, which this baby's dribbling out. In our saliva, we have catalysts that are called enzymes, and these help to break down sugar really quickly, which is why when we eat certain foods, we can taste the sweetness really quickly, because the sugar gets broken down. So we have catalysts in our saliva that breaks down sugar, or breaks down foods into sugar. So these are the four main ways that we can speed up or slow down chemical reactions.